Let's look at an application involving a rational function. The population of deer in a particular forest can be modeled by the function p of x equals 320x plus 2,200 all over 4x plus 5, where x is the number of years in the future from today. So since x is the number of years in the future from today, today would be x equals 0. In fact, our first question, how many deer live in this forest this year? This year would be today, so we'd be saying x equals 0. And then putting that into the function, p of 0, and calculating 320 times 0 plus 2,200, all divided by 4 times 0 plus 5. Now, multiplying anything by 0 is going to make those terms go away. So we get 2,200 divided by 5. Feel free to use a calculator if you're working this out. Any word problem I would have on the calculator portion of the exam, this would give us 440 deer. Remember, in any application, you should always write out your answer in a sentence. So today, there are 440 deer. How many deer will live in the forest 14 years later? So 14 years from today would be x equals 14. So we just do a similar process, but put 14 into the function instead of 0. So 320 times 14 plus 2,200 all over 4 times 14 plus 5. Calculating, feel free again, use your calculator if you want. 6,680 in the top. Remember to calculate numerator and denominator separately. And then 4 times 14 plus 5 would give us 61 in the denominator. And when I divide that, 6,680 divided by 61, I get approximately 109.508. It goes on in my calculator. Notice it says round your answer to the nearest integer. Nearest integer, when we're rounding, if we have a whole number of 109.5, 0.5 means we're closer to 110 than we are to 109. So when we're rounding, this would be 110 deer will be in the forest in 14 years. So remember, write your answer out in words. So there's our answer in our second problem. The next two questions ask us to use Desmos and the graph of this function to answer them. In part C, it says, after how many years will the deer population be 100? So we'd like to use Desmos to answer this. To do that, we would want to graph the function p of x equals 320x plus 2,200 over 4x plus 5. And we want to see where it's equal to 100. That would be graphing the horizontal line of y equals 100. So we graph each of these, and we want to see where they intersect. So we'll look at the intersection of those two graphs to find our answer. And then we'll look at the graph to think about when the population is going to level off and how many deer it levels off to. So let's look at that function in Desmos to answer those last two questions. So we need to type the function in. P of x equals 320x plus 2,200. Now I want to divide all of that by the denominator, so I'm going to highlight it before I hit divided by 4x plus 5. By the way, the other way you can show that you have all of the numerator and all of that denominator in their proper places is by using parentheses around each. Now when we look at the graph, which is in red here, we're seeing the graph in a negative for negative x values. We're not seeing any positive x values. Positive x values will be going forward in time, because remember, x is equal to 0 today, and we want to think about what's happening forward in time, not backward in time. So part of what's happening is I've got the wrong visual window on this graph. So let's change our viewing window by looking at graph settings. Remember, what we want to go is forward in time. So I retain my y-axis. I'm going to go from -5 on the x-axis, and then maybe I'll go out 30 years. So x from -5 to 30. And remember, in the two examples we did earlier, our population of deer were in the hundreds. So I would like to go ahead and maybe have my y-axis be from -10, because that way I can still see my x-axis, and my y-axis go up to maybe 500. So here we have a much better image of the graph in the positive realm. So looking at time as we continue on. And the other thing we were wanting to do in part C was see when is the population equal to 100 deer. So I can say y equals 100, and what I have here is a place with a gray dot where the two graphs cross each other. And notice they cross each other at an x value of 21.25. So that would be in year 21, or 21 years from today, the population of deer will be 100. In fact, one thing you'll notice is the population of deer is going down over time. But if we kept going, it doesn't appear to go down forever. It seems to be stabilizing out to a particular value as we continue here. And in fact, if we look at this red graph and points on this red graph, it seems to be that the y value is approaching around 84. I'll go out a little further. Oh, 83, it's approaching down there. And we can keep going out further and see what it appears to be, 82. One way we can kind of show that instead of continuing to just go out and out is we could say, like, say we wanted to figure out P of, let's go out 1,000 years, 1,000. And notice it ends up being about 80. And then if we did out 10,000 years, it's still really close to 80. So the deer population, even though it realistically would we really be going out 1,000 or 10,000 years? Probably not. But you can see what's happening in the graph is that as we go out further and further, I'll even go out 100,000 years, the population is getting closer and closer to 80 and settling in on 80. So the answer to part C is that the deer population will be at 100 in about 21 years. And then in part D, we see that the population is leveling off to around 80 deer in the long run.